find the standard deviation. Are we together? So for us to find standard deviation, we have to do, right, 62, which is our x, minus, sorry, this is supposed to be mean. So 62 minus our mean, right? 62 minus 67 will give us minus 5. And if you square minus 5, it will give you 25. Then 72 minus 67 will give you 5. If you square 5, it will give you 25. And then when you do it that way, right? Now when you add up the sum of this column, if you add everything, it's going to give you 70. Are we together? Now, so what is the formula for standard deviation? Now, standard deviation is equals to square root of summation x minus x bar, everything squared, all over n minus 1. Excuse me. Alright, now so look at this. We already have the sum of this as what? 70. So we just write 70 over 9 minus 1 will give us 8. So square root of this. So if we divide 70 by 8, you are going to get 8.75. Then square root of 8.75 will give you 2.96. Now, what have we done so far? Now, in the formula, we have gotten the sample mean, which is 67. Then, still from the formula, we have gotten the standard deviation to be what? 2.96. Now, all we need to do now is to slot the values into the formula and then we'll solve it. Now, so let's look at our data. What is our sample mean? Our sample mean is 67. Alright? What is our mu? From the question, our mu is 65. What is our S? Our S is 2.96. Then what is N? Our N is 9. Alright? So now let's substitute these values now. So we have T is equals to what? 67 minus what? Minus 65 all over 2.96 divided by square root of 9. Are we together? Then if you go this way, this will give you 2. 2 divided by 2.96 divided by 3, because the square root of 9 will give you 3. And then when you do everything, right, if you punch everything on your calculator, your T is going to give you 2.03. Alright? So that is your calculated value, your calculated T value. Now, the next step, remember, we are looking at the steps of hypothesis testing. We state our null hypothesis, we state our level of significance. No, level of significance, sorry, please, not LOS, level of significance. Then, test statistic, we have done that. Then we determine what? The degrees of freedom. Now, the next one is degrees of freedom. And degrees of freedom is what? N minus 1. For t-test, remember, we are dealing t-test for single mean. When you get to paired test, paired t-test, you still have different formula for degrees of freedom. Alright, so what is our N? Our N is what? 9 minus 1, which is what? 8. So the next step for hypothesis testing, is we check for critical value. We check for critical value, and then we use the t-test, the t-distribution test. We use the t-distribution test to check that. And when you check on the t-test, the distribution, you are going to get 2.306. Now that is your critical value or your p-value using your t-test. Remember, when you are checking your t-test, you check the one that is two-tailed. Remember we say we have single tail, and then we have a left tail, we have a right tail, and then we have two tails. So since our null hypothesis is telling us that it is our mean population is 62, then you check for two tail, and that will give you this value. So we decide now. How do we decide? Remember, if our decision rule now, if our T calculated value, right? If our T calculated value is greater than our T critical value, right? We reject what? We reject the null hypothesis. We reject our HO. So from our value, you discover that our calculated value was less or is less than our calculated value is less than our T critical value. So what does it mean? It means that we are going to accept our what? Our HO. That means if you are going to accept our HO, it means that the population of the universe is what? Is 65. Alright? Now, if I'm going to draw that on, I'm going to draw this on the normal distribution. I'm going to draw that on the normal distribution. I have something like this. Alright. Remember, this is a rejection region. Since it's a two-tailed test, alright, we are using what? 0.5 as our alpha value. Our alpha value is 0.5. Alright? So, our critical value was 2.306. Okay? So our t-test fall along this acceptance region. It falls here, 2.03. Alright? So that is that about t-test regarding single mean. Thank you very much. Thank you very much.